Welcome back to the world of RoboMate. Students, we have been discussing the chapter rotational motion. Now, we are going to start with the next module of the chapter rotational motion. This module is called as physical significance of moment of inertia. Now, students, we have already defined what is moment of inertia and we have discussed some formulas for moment of inertia. You remember? The previous module we have done this. In this module, we are going to discuss the physical significance of moment of inertia. The importance of moment of inertia. Is that clear? So, are you ready? Fine. Let us start with the module. Physical significance of moment of inertia. Now, students, for this, let me compare two motions. One is your translational motion, the other one is rotational motion. Now here, I can ask you a question. Now I'm getting a chance. I'm going to ask you a question. In translational motion, what causes inertia? Yes? 11th standard you have studied. The previous module also we have discussed. Yes? Yeah. What is that? Very good. In translational motion, mass causes inertia. Now, to move a body, let us say a body is at rest, and you want to move that body, what do you need to do? Yes, very good. We need to apply force. So, to produce linear motion in a body, external unbalanced force should be applied. Yes or no? Fine. And what is the formula for force? Yes, formula for force is mass into acceleration. Is that clear? So, in translational motion, mass causes inertia, and to produce linear motion, you need to apply an external unbalanced force. Okay. Now let us come to rotational motion. In rotational motion, you have all studied, we have discussed what is moment of inertia. Yes, definition. Yes, previous module we have discussed. No, we have discussed. Yes, you are saying something. What is that? Yes, a bit louder. What you are saying is right. The inability of a body to change its state of rotation by itself is called as rotational inertia or moment of inertia. Yes or no? So in rotational motion, we have moment of inertia or rotational inertia. So if a body is rotating, it will continue to rotate. Is that clear? That is your rotational inertia. We have seen this with the example of Earth. Now students, moment of inertia. Now if I want to change the state of rotation, what should I do? Yes, very good. To produce a rotational motion or to change the state of rotation, I need to apply an external unbalanced torque. We have discussed this in the previous module. So if you apply an external unbalanced torque, then the body will change the state of rotation or it will produce rotational motion. And what is the formula for torque? Yes, force into perpendicular distance. No. Here we have one more formula. Torque is I into alpha. I is your moment of inertia. Alpha is angular acceleration. Now this formula we'll be deriving in the upcoming module, so don't worry. So torque acting on a rotating body is I alpha. Now students, what you have to do here is see these two equations. F is equal to ma and torque is I alpha. I can compare both. Force produces linear motion. Torque produces rotational motion. A is your linear acceleration. Alpha is your angular acceleration. So I can say A and alpha, they are analogous to each other. And force produces change in, I mean to say, state of rest or motion, that is, it produces linear motion. Torque produces rotational motion. So, by comparing these two equations, I can say that whatever role mass plays in translational motion, the same role is played by I in rotational motion. Alright. And mass causes inertia in translational motion. So, I causes inertia in rotational motion and I is called as moment of inertia. So, this is very, very important, students. Moment of inertia plays the same role in rotational motion as the mass of the body does in linear motion. Is that clear? Fine. This is very important. Keep this in your mind. So now students, I'm going to discuss some factors that is going to affect moment of inertia. The first factor is the mass, shape and size of the body. Now, if the mass of the body, the shape of the body and the size of the body changes, then moment of inertia of the body will change. Second factor is distribution of mass about the axis of rotation. Mass is closer to the axis, moment of inertia will be different. Mass is far away from the axis, distributed far away from the axis, moment of inertia will be different. Is that clear? The third factor is position and orientation of the axis of rotation. So if you change the position of the axis of rotation, then moment of inertia will change. Now the third factor we'll be discussing more in the upcoming modules. Is that clear? Now, I can bring one example here. Take this rod, alright, and let M be the mass of this rod. I'm going to take a point. This point is at the center of the rod. Now let me consider an axis passing through the center of the rod and perpendicular to the plane of the rod. Now, if this rod rotates about this axis, then its moment of inertia is Ia. I'm going to consider the same rod again. Alright, same rod. Mass is again M, length is also same. But this time I'm going to take a point at one of its end. And now let me consider an axis passing through this point which is at one of its end and perpendicular to the plane. Now if this rod rotates about this axis, then its moment of inertia is Ib. I'm going to ask you a question here. The question is Ib greater than Ia? Yes. How? How? Yes, students, see there. See the second factor. Distribution of mass about the axis. First rod, axis is at the center and the mass is distributed very closely to the axis. Second case, same rod in the second case, axis is at one of the end and mass is distributed far away from the axis. You see here, mass is very far away from the axis. So then, distribution of the mass will change the moment of inertia. So Ib is of course greater than Ia. Is that clear, students? So students, all these factors are very, very important. Keep revising it. So I'll meet you up in the next module. Until then, no one can stop you. Rise and shine.